An astounding revelation by the James Webb Space Telescope has caught the consideration of established researchers. Puzzling lights looking like cityscapes have been seen in space, around 7 trillion miles from Earth. These strange lights exuding from the exoplanet Proxima Centauri b, the nearest known exoplanet to Earth, have filled hypotheses about the chance of extraterrestrial life. The telescope's focus on Proxima Centauri b uncovered these splendid lights, bringing up the issue of whether they could signal the presence of an outsider. Join us as we investigate how the James Webb Space Telescope recognized these uncommon peculiarities and what they could mean for how we might interpret life beyond Earth. For a long time, researchers and the general public alike have anxiously awaited any clue of life outside our planetary group, and this new revelation has sent shockwaves through mainstream researchers. The James Webb Space Telescope, while filtering the universe and sending crucial information back to Earth, recognized bizarre lights that seemed to illuminate a far-off city on Proxima Centauri b. The likely presence of an outsider city on this nearby exoplanet has left researchers both confounded and thrilled, as it could address the very proof of intelligent life they have for quite some time been looking for. If these lights are indeed what they appear, it would suggest that there are advanced civilizations in space that are just now being recognized by humankind. As NASA specialists peer into these far-off city-like lights, they can't help but wonder how long they have been shining in space, waiting for people to develop the technology needed to detect them. David Ewing, a cosmologist from Columbia College, described Proxima Centauri b as an especially precarious planet to concentrate on because of its unique warming patterns, which vary fundamentally from those of other rocky planets. Unlike typical planets that absorb sunlight and emit infrared radiation, Proxima Centauri b displays an infrared signature that is unmistakable from its host. Proxima Centauri b makes it an ideal focus for the James Webb Space Telescope. The telescope's capacity to recognize infrared frequencies has made it the perfect tool for observing Proxima Centauri b's warm emissions and uncovering mysteries about its atmosphere. Researchers are currently utilizing the James Webb Space Telescope to further examine the secrets of Proxima Centauri b, with an emphasis on its environmental components and the potential for habitability. The telescope's infrared responsiveness permits it to investigate what occurs on the world's night side, capturing even the slightest beams of light in the tremendous astronomical darkness. This ability is crucial for checking whether the supposed city lights on Proxima Centauri b are genuine. Each faint light in the universe can be distinguished by the telescope as long as it falls within a specific frequency range, making the James Webb Space Telescope a valuable instrument in the quest for extraterrestrial life. Proxima Centauri b has a captivating connection between its heavenly qualities and surface interactions. The exoplanet experiences constant cycles like those on Earth, with its day side absorbing sunlight and its night side cooling quickly. The temperature changes on Proxima Centauri b, impacted by its atmospheric composition, offer a compelling subject for further study. If the planet lacks an atmosphere, the temperature contrast between day and night would be extreme, while an atmosphere would regulate these variations. The James Webb Space Telescope, with its unrivaled infrared imaging capabilities, is well suited to analyze these thermal emissions and provide insights into the planet's atmospheric properties. Strikingly, the orbit of the James Webb Space Telescope around Earth aligns with Proxima Centauri b's orbital period, allowing for continuous observations of its day and night cycle within 11.2 Earth days. If Proxima Centauri b indeed has an atmosphere, the next step will be to assess its chemical structure to determine whether it could support life. Indicators such as oxygen, water vapor, and methane would suggest that the planet has habitable conditions. However, identifying these components requires meticulous analysis of light passing through the planet's atmosphere, a challenging task even for a telescope as advanced as the James Webb. While the James Webb Space Telescope has its limitations, especially in detecting reinforced oxygen, a critical marker of life, it remains an outstanding asset for studying the environmental conditions of distant exoplanets. Researchers are also anticipating future ground-based observatories, such as the Extremely Large Telescope, ELT, set to begin operations in 2028. The ELT will offer further insights into the atmospheric patterns of distant exoplanets, supplementing the discoveries made by the James Webb Space Telescope. Regardless of its current constraints, the James Webb Space Telescope continues to play a significant role in our mission to uncover the secrets of distant exoplanets. Its ability to analyze the faintest impressions of light from far-off planets allows for a distinctive assessment of their atmospheres and the potential for life. This undertaking, however, comes with its own challenges, as researchers must distinguish between gases produced by biological processes and those generated by geological activity, such as volcanic eruptions. The James Webb Space Telescope represents the forefront of scientific advancement in the exploration of exoplanets. Its observations offer a preview of the astonishing discoveries on the horizon as we push the limits of our understanding of the universe. As we explore further into space, the telescope will continue to provide valuable information on distant worlds, helping us unravel the mysteries of these far-off planets. Years ago, the domain beyond our solar system was largely overlooked. Since then, astronomers have identified over 4,000 exoplanets orbiting distant stars, showcasing the extent of human ingenuity. Yet, NASA considers these discoveries to be only the tip of the infinite iceberg, with trillions of exoplanets still awaiting discovery. Researchers are determined to explore these unknown worlds in the hope of finding extraterrestrial habitats where humans have never ventured. Throughout the years, there have been glimmers of hope in the search for extraterrestrial life. For instance, when the Galileo spacecraft traveled to Jupiter, its spectroscopic instrument detected a remarkable spectral signature suggesting the presence of extraterrestrial vegetation, the first biosignature indicating life in the universe. This biosignature, known as the vegetation red edge (VRE), reflects light in a manner that could reveal the presence of alien life. The James Webb Space Telescope, equipped with VRE capabilities, is expected to unveil the secrets of extraterrestrial conditions by mapping the orbital characteristics of potentially habitable planets within their stars' habitable zones. Once identified, the VRE could provide pivotal evidence in the search for intelligent life beyond Earth. As sunlight passes through a planet's atmosphere, the light is absorbed by particles and atoms, creating a distinctive spectral pattern that can be analyzed through spectroscopy. This pattern serves as a unique fingerprint, allowing researchers to interpret the atmospheric composition of distant planets. It is speculated that the James Webb Space Telescope could detect light as it enters a planet's atmosphere, providing insights into the planet's atmospheric makeup. Earth-sized planets with atmospheres rich in carbon dioxide, nitrogen, and oxygen might be able to support life. However, the absence of unusual compounds could indicate alternative forms of life or advanced civilizations. Compounds like chlorofluorocarbons, CFCs, which are man-made and used for refrigeration and industrial purposes, could serve as signs of extraterrestrial civilizations. If the James Webb Space Telescope were to detect these compounds on another planet, it could provide strong evidence of alien life. Although the telescope currently has limitations in its ability to detect certain components, it remains an essential instrument for studying exoplanets and advancing our understanding of the universe. Researchers hope to reduce the brightness of a planet's host star, allowing for better observation of faint light reflected from the planet itself. They aim to achieve this by using internal masks or large external satellites, akin to using an umbrella to block out sunlight. Future telescopes will be able to study the faint impressions of light from distant exoplanets more effectively, leading to a clearer examination of their atmospheres and their potential to support life. This approach will help astronomers differentiate between gases produced by life and those generated by geological processes. Even as researchers work to refine their methods for studying exoplanets, they continue to explore the universe in search of signs of life. The James Webb Space Telescope, with its unparalleled capabilities, offers a glimpse into the future of space exploration and the potential discoveries that await us. As we continue to expand the limits of our knowledge, we are better prepared to understand the complex workings of the universe and our place within it. Despite decades of searching, researchers have yet to find conclusive proof of life beyond Earth. However, the mission continues, driven by humanity's enduring curiosity about whether we are alone in the universe. For centuries, humans have wondered whether they are the only intelligent beings in existence, a question that remains unanswered to this day. The James Webb Space Telescope is just one of the many tools being used to search for extraterrestrial intelligence. As researchers study a wide variety of planetary bodies for signs of life, a popular hypothesis suggests that extraterrestrials may indeed be out there, simply waiting for humans to find them. To answer this question, American astronomers Jill Tarter and Thomas Pearson established the Search for Extraterrestrial Intelligence (SETI) Institute in 1984. The nonprofit organization focuses on sifting through large transmissions, especially radio signals, which can travel significant distances without being dispersed or absorbed, making them more likely to be detected. The 42 radio telescopes of the Allen Telescope Array in California's Sierra Nevada have been scanning these signals for over 30 years. Despite this, no conclusive evidence of extraterrestrial life has been found. Nevertheless, Jill Tarter remains hopeful, expressing confidence that the tools of the 21st century will accelerate the search. She encourages Earthlings everywhere to become active participants in the ultimate quest for cosmic companions. This journey continued until recent reports from NASA suggested that the James Webb Space Telescope had detected city-like lights on a nearby planet. The telescope, considered humankind's most advanced instrument for exploring the universe, is currently orbiting around 1 million miles from Earth, sending back data that researchers hope will reveal whether intelligent life exists on other planets. Astronomers use spectrometers to analyze light emitted by exoplanets and their host stars, allowing them to gather essential information about the planet's atmospheres and determine their potential for habitability. The James Webb Space Telescope can measure infrared light frequencies and detect gases essential for life, such as water vapor, oxygen, methane, and carbon dioxide. By examining the light patterns of these gases, researchers can gain valuable insights into a planet's ability to support life. While the James Webb Space Telescope has its limitations in detecting specific components, such as oxygen, it remains a critical tool for the exploration of exoplanets. The telescope's ability to analyze light in the infrared range enables researchers to determine the chemical composition of a planet's atmosphere and assess its potential to support life. Despite the challenges that continue to face the search for extraterrestrial life, the James Webb Space Telescope marks a significant step forward in our understanding of the universe and our place within it. As researchers continue to study the data sent back by the telescope, they remain hopeful that one day they will find conclusive evidence of life beyond Earth. The James Webb Space Telescope, JWST, has made an earth-shattering discovery that has dazzled both researchers and the public. Odd lights that appear to resemble those of a city have been identified on Proxima Centauri b, an exoplanet orbiting the nearest star to our solar system, located roughly 4.24 light-years from Earth. Proxima Centauri b has been a subject of intense study since its discovery, primarily due to its proximity and its potential to harbor life. The lights, which seem to illuminate portions of the planet's surface, have led to speculation that they could be artificial in origin, perhaps the result of a high-level extraterrestrial civilization. The JWST, with its exceptional ability to capture infrared light, has been instrumental in observing Proxima Centauri b in greater detail than ever before. The telescope's advanced sensors have detected these strange light patterns during its survey of exoplanets within our cosmic neighborhood. These observations have ignited excitement and interest among astronomers, who are now diving deeper into the data to understand the nature and source of these lights. Proxima Centauri b orbits within the habitable zone of its star, Proxima Centauri, meaning it could have conditions suitable for liquid water, a critical element for life as we know it. This makes the discovery of potential artificial lights all the more intriguing, as it raises the possibility that life on this planet could have evolved to the point where it can produce large-scale light, much like human cities on Earth. If these lights are indeed artificial, they could represent a civilization that is either contemporaneous with humanity or perhaps significantly more advanced. The detection of these lights was made possible by the JWST's sophisticated instruments, which are capable of identifying faint infrared emissions that other telescopes might miss. Infrared light, which is emitted by warm objects, can penetrate dust clouds and reveal details that are otherwise hidden in visible light. This capability has allowed the JWST to observe Proxima Centauri b's night side, where these lights were detected. It is not simply suggested that they are reflections of starlight, but potentially something much more extraordinary. One of the main challenges in confirming the nature of these lights is distinguishing between natural and artificial sources. Natural explanations could include volcanic activity, bioluminescent organisms, or even reflections from the planet's surface features. However, the intensity and consistency of the lights observed by the JWST seem to contrast with typical natural phenomena, prompting researchers to consider the likelihood of an artificial origin. As a result of this revelation, astronomers are conducting follow-up observations using both the JWST and ground-based telescopes. These observations aim to gather more information on the light emissions, including their spectrum, which could provide clues about their composition. By investigating the spectrum, researchers hope to determine whether the lights are produced by gases in the planet's atmosphere, surface materials, or artificial structures emitting light like cities on Earth. The implications of discovering an extraterrestrial civilization on Proxima Centauri b would be profound, not only for our understanding of life in the universe but also for humanity's place within it. Such a finding would challenge our assumptions about the uniqueness of intelligent life and could potentially lead to a new era of interstellar communication or even exploration. However, researchers remain cautious, as extraordinary claims require extraordinary evidence, and there is still much to learn before any definitive conclusions can be drawn. In the meantime, the JWST continues to observe Proxima Centauri b alongside other exoplanets in neighboring star systems, searching for further clues. The telescope's ability to probe the atmospheres of these distant worlds and identify signs of habitability makes it a central player in the ongoing quest for extraterrestrial life. Whether the lights on Proxima Centauri b turn out to be artificial or natural, the discovery has already sparked renewed interest in the search for life beyond Earth. This finding also highlights the potential of the JWST to reshape our understanding of exoplanets. As the telescope continues its mission, it is expected to uncover much more about the universe, from the nature of distant systems to the composition of exoplanet atmospheres. Each new finding brings us closer to answering some of the most fundamental questions about our universe. Are we alone, or is life a common occurrence in the vastness of space? For the time being, the lights on Proxima Centauri b remain a puzzle, but they serve as a reminder of the possibilities that lie beyond our solar system. As technology advances and our observational capabilities improve, we may one day find conclusive proof of life elsewhere in the universe. Until then, the search continues, fueled by the tantalizing clues provided by the JWST and the enduring human desire to explore the unknown. The discovery has also prompted discussions about the potential for future missions to Proxima Centauri b. While current technology does not allow for interstellar travel within a human lifetime, ideas like Project Starshot, a proposed mission to send small light-propelled probes to the Alpha Centauri system, are being explored. If successful, such missions could provide a closer look at Proxima Centauri b and potentially confirm the presence of an extraterrestrial civilization. As the scientific community continues to analyze the data from the JWST, the world watches with bated breath, considering what other secrets this distant exoplanet might hold. Whether these lights turn out to be natural or artificial, their discovery marks an exciting milestone in the ongoing exploration of the universe and the search for life beyond Earth.